Hi, welcome to my channel. I'm Aravindan. This is the fourth lesson in electric field. Mainly I focus Edexcel, Cambridge and international baccalaureate syllabuses. But students, those who are following AQA OCR also can follow this lesson, right? Okay, today we are going to learn about neutral point or null point. What is it? Null point or neutral point? Actually, null point or neutral point in electric field is called the point at which the net field strength, that is the resultant electric field strength, is equal to zero. So how is it possible? So just one point charge can't create a neutral point in space. At least there should be 2 point charges, but there can be more point charges. They can create neutral point in space, but just one point charge can't create a neutral point in space. Okay, for example, if I consider two positive point charges in space, imagine this is Q1, a positive charge, and there's another point charge Q2 that also positive. Then they might have different magnitudes. On along this line, say if I consider x and y are the 2 points, on the line xy, certainly there will be a neutral point. That means imagine if I consider point P, the direction of the electric field created by Q1 at point P will be towards right. I already told that how to find the direction of the electric field strength. Keep a positive test charge at point P, so that will experience electrostatic force towards right. So the direction of the electric field strength due to Q1 at point P will be towards right. Let it be E1. Same way, when you keep a positive test charge at point P, the direction of the electric field strength due to Q2 will be towards left. So let it be E2. So if E1 equal to E2, if the magnitude of E1 and E2 are same, they will cancel each other because they are in opposite direction to each other. So the resultant electric field strength at point P will be equal to 0. So P will be a null point or neutral point. Okay, so we'll do a question, how to calculate the distance of a null point from a charge. We can calculate that. That will be the next question. Okay, null point or neutral point refers the same. Now this is the question. There are two positive point charges, 15 microcoulomb and 10 microcoulomb, are kept at 2 points, two different points, x and y. The distance between x and y is 20 centimeter, right? So the question is, find the distance of the null point or neutral point from x. Okay, so there are many different possibilities. You don't know where to find it. Okay, I can say we'll try some points and we'll decide whether those points can be a null point. Okay, we'll see. If a student says, okay, a null point is on left of x, maybe he's saying, okay, this point can be a null point. I'll call that point n, right? So can this n along the same line of xy, can it be a null point? Is it possible? So I told at that point the resultant electric field strength must be equal to 0, right? That means if 2 point charges are creating a null point, then at that point the direction of the electric field strength due to those 2 point charges should be in opposite. Then only they can cancel each other, is it? So if I consider, is it possible that point n can it be a null point? Okay, we'll think like this. If I keep a positive test charge, 15 microcoulomb will repel it. 10 microcoulomb also will repel it. So the electric field strength due to 15 microcoulomb, if I say that is E1, same way, the electric field strength at point N due to 10 microcoulomb, that also towards left E2, certainly they will not cancel each other because they are in the same direction. So N can't be a null point. Or I can simply say a point which is on the left of x cannot be a null point. Okay, same way, we'll check whether is it can there be a point on right of y along the same line? Can there be a point on right of y as a null point? Okay, we'll see. We'll analyze. I'm drawing the diagram separately. So this is x. So this is y, right? So here 15 microcoulomb, here 10 microcoulomb. Okay, I proved that any point on left of x along the line yx cannot be a null point. Similarly, we'll check whether there can be a point along the xy on the right of y. Say imagine a point n. Is it n can it be a null point? Is point n, can it be a null point? Okay, we'll try to keep a positive test charge at that point. If I keep a positive test charge at point n, what will happen? 10 microcoulomb will repel it. So the electric field strength due to 10 microcoulomb will be towards right. 15 microcoulomb also will repel it. So I'll mark it here. That is E2, right? E2 also will be towards right. So certainly they will not cancel each other because E1 and E2 are along the same direction. So any point on the right of y along the line xy cannot be a null point. Okay, then we will find, we'll try to find a point somewhere out of this line xy. So imagine a point somewhere here in space, arbitrary point. I can take here or here or here, just randomly I'm taking a point here. Is it possible? Can n be a null point? Okay, we'll try to keep a positive test charge. If I keep a positive test charge at this point, the 15 microcoulomb will repel it. So that will be along this direction. So E1 will be this direction. Same way, the 10 microcoulomb will repel it. So the electric field strength due to 10 microcoulomb at n will be this way. Certainly, they will not cancel each other because you know, if two vectors want to cancel each other, they should have the same magnitude and they should be in opposite directions. So certainly, any other point outside the line xy also cannot be a null point. So where can be a null point? It must be somewhere between xy. Okay, so I'll find this point. I don't know where will it be. I'll just take this point as a null point, right? So the question is, find the distance of the null point from x. So take that distance from xn, let it be d. And they said xy is 20 centimeters. So ny, from n to y, the length ny will be equal to, I can keep it in centimeters, so 20 minus d. Okay, now we'll check, is it possible, n, can it be a null point? Yes, it can be. Like, imagine if I keep a positive test charge, 15 microcoulomb will repel it. So the electric field strength due to 15 microcoulomb at point n will be towards right. Let it be E1. Same way, the electric field strength due to 10 microcoulomb at n will be towards left, E2. Right, now there is possibility because at n, the direction of the electric field strength of 15 and 10 are in opposite direction. Only thing, they should have the same magnitude. So E1 and E2 can have same magnitude depending on the direction, is it? So we will find the direction D such that E1 and E2 get the same magnitude. Then they will get cancel each other. So simple the equation. So if n is null point, or if n is a null point, then I can say E1 minus E2, they are in opposite direction, must be 0. I can take it to the right. So E equal KQ over R squared. So I can say K times Q1, that is 15 microcoulomb, 15 into 10 to the power minus 6 over R squared is D. The distance is D squared equal to, I'll take it to the right side of the equal sign. So E2 equal, once again, KQ over R squared. K is 10, K we are not substituting, they are going to get cancelled. K into, charge is 10 microcoulomb, so 10 into 10 to the power minus 6 over, the distance is 20 minus D all the squared. Okay, so you know how to solve this equation, simple equation. K and K will get cancelled, 10 and 10 will get cancelled. Then 15, 10, both sides I can divide by 5, so it will become 3, it will become 2. Anyway, you know how to solve them. You can then after that cross multiply, is it? Uh, and take the square root on both sides. So when you take square root on both sides, you will get this equation. It will come, you will get something like 1.73 because k and k get cancelled, 10 to the power minus 6, 10 to the power minus 6 will get cancelled. If I divide both each side by 5, this will be 3, this will be 2. Then take square root on both sides, you will get 1.73. 1.73 is square root of 3, cross multiply and take square root. 20 minus d equal square root of 2 is 1.41, yeah, into square root of d square is d. Then solve it, you will get the answer. D will be equal to 11 centimeters. Okay, so there will be a null point or neutral point from x at a distance of 11 centimeters. You can see that that is more than 10. 10 is the midpoint of x and y. It's more than 10 centimeter, 11 centimeter, because it will be more closer to y. The reason, this is more stronger charge than this one, is it? So the null point will be far away from a stronger charge or larger magnitude of charge. Okay, so in this question, there are 2 point charges. One is a negative charge, negative 10 microcoulomb, and the other one is a positive charge. Okay, so the idea is the same, the theory is the same, but one is negative, the other one is positive there. Okay, the question is find the distance of neutral point from x. Again, from the point x, they ask me to find the neutral point, distance of neutral point. Okay, so here also we will analyze where can be the null point. Can it be on the left of x, or can it be on the right of y, or can it be somewhere out of line xy? We'll analyze it, then we'll calculate the distance. Okay, so I'll draw the same thing again. This is x, this is point y, this is minus 10, this is 2 microcoulomb, right? Okay, now where can it be? Can it be on the left of x? The neutral point, can it be on the left of x? Is it possible? Right, now we'll think about that. Okay, if the neutral point is on the left of x, that is if I take that neutral point n, okay, keep a positive test charge at n. If I keep a positive test charge, the 10 microcoulomb will attract it. So it will be towards right. It will be E1, right? Now, when I keep a positive test charge, the 2 microcoulomb will repel it. So that will be towards left. The E2 will be towards left, right? Now, these two are in opposite direction, but is it possible? Can they cancel each other? That's the question. Can they cancel each other? No, they can't, because even though they are in opposite direction, never they will have the same magnitude. The reason is, you can see E1 is due to 10 microcoulomb, negative 10 microcoulomb. The magnitude is large. If you think about E1, that will be E1 equal k times 10 into 10 to the power minus 6, just for the micro, over the distance is, say, let it be d1 squared. This distance, let it be d1 squared. But E2, that is towards right, is it? E2 will be k times 2 microcoulomb, 2 into 10 to the power 6 over, that will be d1 plus, this distance is 10, d1 plus 10 squared. I can convert to meter, but I'm just analyzing it, so I'm not converting the units. Now look at here. Can they cancel each other? Never, because when you consider E1 and E2, they are in opposite direction. Yes, that is true, but the numerator for E1 is larger than E2. In this fraction, the numerator 10, this numerator is 2. Then denominator of this one is larger again. So obviously, certainly, E2 will be smaller than E1. So never they cancel each other. Okay, so there can't be a null point in this example, in this question. The null point cannot be on the left of x, never. I hope you understood this, is it? Okay, can it be somewhere between x and y? Is it possible to have a null point between x and y? Okay, imagine a point somewhere between x and y, let it be n, somewhere here. Then the electric field strength due to 10 microcoulomb will be towards left, because if I keep a positive test charge at n, that will be attracted by 10 microcoulomb. So the E1 will be towards left. Then the electric field strength due to 2 microcoulomb, that is going to repel positive test charge when I keep it on n. So the E2 also will be towards left. E2 also will be towards left. So since those two vectors are in the same direction, they won't cancel each other, never. So that means there can't be a neutral point between x and y on the same line xy, right? So I derived, or I proved, that null point cannot be on the left of x. Null point cannot be on the line xy between x and y. No. Same way, if I take arbitrary a point outside x and y, xy, so take a point somewhere here. So same thing I explained when I started this lesson. So again, the same explanation. So the E1 due to x will be along this line. E1 will be this way. E2 will be this way. So obviously, certainly, they will not cancel each other, because you know the condition for two vectors to cancel each other. They should have the same magnitude. They should act on the same line of action in opposite direction. Is it two vectors if they want to cancel? So they are not acting on the same line. So certainly, E1 and E2 will not cancel each other, and null point cannot be on any other, cannot be outside of xy. So the only possibility, the null point can be only on the line xy on the right side of y. Is it possible? We'll see. If I say this as a null point, that's the only possibility, but we'll check, is it possible? Yes. Now when I consider the point n on the right side of y, keep a positive test charge, the 2 microcoulomb will push it. So that will be, let it be E1, that is due to 2 microcoulomb. Then 10 microcoulomb is a negative charge. So the positive test charge will be attracted towards x. So E2 will be towards left. Right, E2 will be towards left. Now they have opposite direction on the same line, but can they have same magnitude? We'll see. If I say E1 will be equal KQR square, K times Q. I said this is due to 2 microcoulomb, so 2 into 10 to the power minus 6 over R square. The distance, I'll take it as D, the distance of the neutral point from Y, let it be D. So that will be KQ over D squared. Now E2, that is, E1 is towards right. E2 will be towards left, that is the electric field strength due to negative 10 microcoulomb. Right? So the direction of E2 is towards left. The magnitude will be K into 10 into 10 to the power minus 6. Because since I already defined the direction, I don't need to put negative sign here. Right? So I'm not using negative sign here because I already decided the direction. Right? Over R square, the distance is actually the distance between 10 and, X and Y is 10 centimeter. So that will be 10 plus D squared. Okay, now is it possible? Can they have same magnitude? Yes, they can have, because when you consider numerator of E1 is now k common 10 to the power minus 6, 10 to the power minus 6 common, right, for both equations. Now this is numerator 2, this is 10, so this is 5 times greater. But at the same time, the denominator, this is D, this is 10 plus D. Okay, so there's a possibility, because numerator is larger, denominator also larger, so they can cancel each other because they can have same magnitude, and certainly they'll cancel because they are in opposite direction. So if I equate these two, I'll get the numerical value for the distance d. So if n is a neutral point, not if, it will be a neutral point, only thing we need to find the distance. So E1 will be equal to E2. right? E1 means k into 2 into 10 to the power minus 6 over d squared equal to k into 10 into 10 to the power minus 6 over 10 plus d squared, because we measure it from, sorry, I think I meant, sorry, it's okay, 10 plus d squared, right? Okay, no problem. We'll find the d. Then we'll add it with 10, right? Okay, so now solve it. So 10 to the power minus 6, 10 to the power minus 6 will get cancelled. K and k will get cancelled, right? So 2 I can divide, this will become 5. Take it to the right side and bring it, you know how to write those things. So 2 will get cancelled. 10 plus 2, sorry, 10 plus d, 10 plus d, if after I take the square root, yeah, if you want I can write one step. 10 plus d squared is equal to, 10 plus d squared is equal to, I cancelled 10 by 2, I divided, so 5d squared. So both sides take square root. When you take both sides square root, it will become root 5. Left side 10 plus d is equal to square root of 5 into d. Anyway, you are using calculators, you can use all of you and find the d. Okay, you will get d equal 8.1 centimeters. So d is measured from point y, is it? D is measured from point y. The question is from point x. So the distance of the neutral point from x will be, this is 10 centimeter. So 10 plus 8.1, that will be 18.1 centimeter. Okay, so the final answer, I can call it as capital D, the distance of the neutral point from x, that will be 10 plus 8.1. I think Greek is not clear. 10 plus 8.1, that will be 18.1 centimeter.